All right, for this problem, let's read it out. So the Dufferin arch is a parabolic arch. Yep. And it says the dimensions are 22 meters across and 20 meters high. So I'm actually going to take a moment. I'm going to draw that. So I'm going to draw what the arch looks like. So it looks like this. And we know that the graph is 22 meters across. And its height is 20 meters. Now it says sketch the graph. So the reason why I drew this is because I always want to have my object drawn, and then I'm going to draw my axis where I want my parabola to be. So in this case, I'm going to imagine that this spot here on the right side is the start of my arch. And it says, sketch the graph of the arch to the left of the base located on the x-axis 4 meters from the left. So if I travel 4 meters from the left, that would look something like this. So that might be 4 meters here. So, but it's 4 meters back from the y-axis. So I would label this as -4, 0 if I was looking at that specific point. Okay, so if I'm looking at that specific point, it's -4, 0. Now, it says, so if I know that this is -4, 0, that means 4 is taken off of here. So there's supposedly, right, to the right of the y-axis, 18 meters here. So that means that this point here, which I'm labeling in green here again, is 18, 0. Now, it says, sketch the graph of the arch to the left of blah, 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 and then label the x-intercepts. And we've just done that. Hey, we've done it. So A is done. A is done. Okay, so we've graphed everything that we needed to do. So when I look at these problems, I tend to try to model it first and then follow what they've asked us to do. So now let's talk about determining the equation. So if you're not sure about how we determine the equation of a parabola, make sure you take a look at the last lesson in the last video or lesson in lesson 3.3. It's a similar type problem. So now, here's what we do. First of all, what we need to do is we need to set up our basic equation. So based on our basic equation, these two values here and here represent the x-intercepts. So let me tell you what the x-intercepts are. If I look at these points, the x-intercepts, based on what my first point is right here, is whatever the x value is on this x-axis here. So in this case, my first x-intercept is x equals -4. And my second x-intercept is right here on the rightmost portion of my graph. And that is when x is 18. So I got x is equal to 18. Now, we need to use this basic equation. Y is equal to a x minus r, x minus s, to find those values. Now, remember that I called these things the roots, right? And when we used these roots, these x-intercepts, what we did was we used the opposite of what those values were inside these brackets here. And what that produced for us was an equation that would look something like this. Y is equal to a x minus, not minus, but it's plus 4 because we start with x is negative 4, and then it becomes plus 4 in the bracket. And then we do the same for 18. So we have, instead of x is 18 here, it's going to be x minus 18 here. So now that I've got that basic setup, what this allows me to do is it allows me to figure out what my a value is. Now, let's go back to our graph. We know that up here, the height of the graph is 20. Now, it is 20, so I know that my y value is going to be 20. But we need to find this value here. We need to find the x value that's exactly halfway between negative 4 and 18. So here's how we find that. We know of a certain property. It's called the axis of symmetry. The axis of symmetry is going to be using basically negative 4 and positive 18. We're going to add them together. So we've got negative 4, I'm putting it in brackets, plus 18. Hit enter on your calculator, get an answer. Then divide it by 2. And you get an axis of symmetry of x is equal to 7. So now that I know that my axis of symmetry is 7, I can go back to my original graph up here, and I can actually put my vertex. So my vertex in this point is, well, 720. So now that 720 isn't on one of the x-intercepts. So we can use that as the x and y in our graph to find the a value for this problem right here. So we just need to be able to find the a value to be able to tell us what our equation is. So let's go and do that right now. So let's begin. So we're going to sub x and y equaling 720. And now what we need to do is we need to sub into the equation that we used before. And when substituting, you're going to get this. And the substitution gives us this. And now you end up with 20 is equal to a times 11 and minus 11. Now, if you end up with something like this, you know with the intercept form of the equation, if you get that for the stuff on the left side, you know you've done your substitutions correctly and you've done your AOS correctly. If not, you got to go back and check to make sure that your AOS has been calculated properly, because if you do it right, when you plug in your values here, you end up with 11 and then minus 11. Or if you plugged in something else, you would have the opposite of the number in each bracket. So now you end up with the following. And so now when you solve for a, you end up with a is equal to 20 over 121. But remember that 121, I missed it, is negative, because 11 times negative 11 is negative 121. So this overall thing is negative. So when you find your a value, if your a value doesn't match what you were starting with, i.e. a negative parabola, then you know you've done something wrong. You can quickly check like I did. And so now you just have to restate your equation. So the equation is y equals and you just substitute your a value, negative 20 over 121, x plus 4, x minus 18. And there you have it. There is your equation. Now you can go and do your homework tasks. Good luck.